Good morning, sir. Haswan, and today I'll be giving a brief description on file system management in Linux. Linux file systems refer to how Linux-based computers organize, store, and track system files. In Linux, there's a combination of directories or folders that serve as a placeholder for addresses of other files and files itself. But there is no distinction between a file and a directory in Linux, and a directory is considered to be a file containing names of other files. A directory may contain software program services etc files inside it, but it will be considered a file itself. Now, one important concept is file locking. So Linux doesn't automatically lock files, open files, but there are two types of locking. One is advisory locking, which works only if the participating processes are cooperating by explicitly echoing locks. Otherwise, advisory locks will be ignored if a process is not aware of locks at all. And the second one is mandatory locking, which doesn't require any cooperation between the participating processes. Once a mandatory lock is activated, the operating system prevents other processes from reading or writing the file. Now, the directory structure in Linux is unique. There is only one top root directory, and all other directories are located inside this single root directory. This is possible because even if a file system is on another physical drive, or we use a removable drive or a pen drive, it can be mounted on a mount point as a part of the root file system tree. Hence, it becomes part of the root directory itself. So directory structure, Linux has the following directory structure as we already know. The top root directory, and every other directory starts from that directory, and only the user has the privilege to write in this root directory. And every directory contains specific types of files. For example, the slash def contains device files, slash etc contains the configuration files, etc. Now, mounting in Linux. The mount command is used to mount file systems in Linux. This command displays all the mounted devices the file system type is mounted as and the mount point. This command can also be used to separately check and mount the unmounted partitions. Now we have access list, which is there are three classes of users in Linux. So that is the owner, group, and public. And a chmod command is used to assign permissions to these users in Linux. For example, chmod 761 means that the owner will have read, write, execute permission. Group access will have group will access read and write permissions only, and the public can access only the execute permission. So after this, we have the file system types. So Linux supports reading around 100 partition types, but it can create and write to only a few of these. But it is possible to mount file systems on different types of the same root file system. In this context, we are talking about file systems in terms of the structure and metadata required to store and manage the user data on a partition of a hard disk or a logical volume. So the main purpose in supporting the ability to reach so many partition types is to allow for compatibility and at least some interoperability with other computer systems, file systems. So we have file system implementation in Linux, and this is done in a two-part file system software implementation, which we'll be going to look at later. But first of all, let us come to what a namespace is. So all file systems need to provide a namespace, that is a naming and organizational methodology. This defines how a file can be named, specifically the length of a file and the subset of characters that can be used for the file names. It also defines the logical structure of the data on a disk, such as the use of directories for organizing files instead of just lumping them all together in a single huge conglomeration of files. Okay, so once the namespace has been defined, a metadata structure is required to is necessary to provide the logical foundations of the namespace. So this includes the data structures required to support a hierarchical directory structure, structures to determine which blocks of space on the disk are used and which are available, maintaining the name of the files and the directories, and information about the files such as size and times they were created, modified, last access, etc. And also the location of the data belonging to the file on the disk. Other metadata is used to store high-level information about the subdivision on the disk, such as logical volumes and partitions. This higher level metadata is and the structure is it represents contain the information describing the file system stored on a device or partition, but this is separate from and independent of the file system metadata. So after this, we have the application programming interface, that is API. So file systems require an API that provides access to system function calls and manipulates file system objects like files and directories. APIs they do the task for creating, moving, and deleting files. It also provides algorithms that determine things like where a file is placed on a file system. Such algorithms may account for objectives such as speed or minimizing disk fragmentation. This is, in fact, we know that while accessing a file, first its address is its logical address needs to be converted to its physical address on the disk. So all of this is done by the API here. And as for security, modern file systems also provide a security model, which is a scheme for defining access rights to files and directories. The Linux file system require model to ensure model helps to ensure that users only have access to their own files and not those of others or the operating system itself. For example, we had the access list, right? So the uh, only the access that is given to the particular group, particular users, only they can do such tasks such as read, write, or execute. Now we come to the two-part implementation in Linux. So the final building block is the software required to implement all of these functions that we just described above. And Linux uses a two-part software implementation as a way to improve both system and programmer efficiency. So we see the kernel, the virtual file system, the file types, and the hardware basically. So the two-part implementation, the first part of the two-part implementation, in this the virtual file system provides a single set of commands for the kernel and developers to access all types of file system. The virtual file system software calls the specific device driver required to interface to the various types of file systems. And this is basically the communication part between uh, communication, the system calls that has to be made to the device drivers, etc. So, and the file system specific device drivers are the second part of this implementation. So the device drivers interprets the standard set of file system commands to one specific uh, to the type of the file system on the partition or logical volume, and hence it completes or accomplishes the task that's required. So basically, this is all for the presentation on the implementation of file systems in Linux, file system management in Linux. Thank you.